Hello everyone, my name is Andy, and today I will be taking you through this exam style question. Now, samples of three substances A, B, and C sit on a bench in front of a class. The amounts of each substance are shown in the diagram below. For A, we have 160 grams of calcium oxide, B, we have 100 mils of H2O, and C, we have 80 grams of oxygen gas, which is O2. Now, for column A, we were first asked to calculate the number of moles of calcium oxide there is. So we know that calcium oxide is simply calcium and oxygen in the 1-to-1 ratio. So the molecular mass of calcium oxide should be 40.1 plus 16.0, and that adds up to 56.1 grams per mole. Now we know that moles is equal to little m over big M, so N will be equal to 160 divided by 56.1. And if we type this into the calculator, we will get 2.85 moles of calcium oxide. For the next parts, we are asked to calculate the number of moles of atoms there are. Now, from the previous answer, we got 2.85 moles of calcium oxide, and we know that for every calcium oxide molecule, we will have two atoms. So we can simply times 2.85 by 2, and we will get 5.70 moles of atoms in calcium oxide. For the last part, we are asked to calculate the mass of oxygen that's present. Now, from the previous answer, we know that 2.85 moles of calcium oxide is equal to 16 grams of calcium oxide, and for every molecule of calcium oxide, there is only one oxygen. So it is correct to say that there is 2.85 moles of oxygen in the calcium oxide. Now, if we sub this into the mole formula, which is N is equal to little m over big M, N will be equal to 2.85 and big M will be equal to 16, as that's the molar mass of oxygen. And if you cross multiply that, you will get M is equal to 45.6 grams. For column B, we are asked to calculate the number of moles of water there is, given that the density of water is 1 grams per mil. We know that 100 mils of water is also equal to 100 grams of water, and so we need to find the molar mass of H2O, which is 1.01 times 2 plus 16, and this adds up to 18.02 grams per mole. We need to use this equation, N is equal to m over big M, and N will be equal to 100 divided by 18.02. And if you type this into the calculator, you will get 5.55. For this next part, we're asked to calculate the number of moles of hydrogen atoms there are. So we know from the previous question that there is 5.55 moles of water in 100 mils of H2O. And we know that for every H2O molecule, there are two hydrogen atoms. So you can simply times 5.55 by 2, and you will get 11.1 moles of hydrogen atoms. For this last part, we are asked to calculate the mass of oxygen that's present. We know that for every H2O molecule, there is only one oxygen atom, which means we will also have 5.55 moles of oxygen in the 100 mils of H2O. So if we use the molar equation again, we substitute N is equal to 5.55, and the molar mass of oxygen is 16.0. So if you cross multiply that, you will get M is equal to 88.8 grams. Now, for column C, we are asked to calculate the number of mole of oxygen molecules that are in the 80 grams of O2 gas. But be careful, we are asked to calculate the number of moles of oxygen molecules, not oxygen atoms. So therefore, for the molar mass, we're calculating for two oxygen atoms to make up the oxygen molecule. So the molar mass will be 16 times 2, which is 32 grams per mole. Now, we would sub this into the molar equation, and N will be equal to 80 divided by 32, and we will get 2.5 moles of oxygen gas. For the second part, we are asked to calculate the number of moles of oxygen atoms. We can either choose to use the method we used previously, or we can simply times 2.5 by 2. This is because there are 2 oxygen molecules in every O2 gas, so therefore we have twice the amount of moles of oxygen atoms. So 2.5 times 2 is equal to 5. Using the other method, we would take the molar mass of oxygen to be 16 instead of 16 times 2, as we're only working out the oxygen atoms. And this will make it so that N is equal to 80 divided by 16, and we will still get 5 moles. Now, for the last part, we are asked to calculate the mass of oxygen that's present. Well, there are only 80 grams of O2 gas, and we know that oxygen is made up of oxygen atoms, so therefore it would just be 80 grams since it's only asking for the mass of oxygen.